another exciting episode here at IT Pro TV. I'm your host, Wes Bryan, and in today's episode, we're continuing through our series inside of VMware. That's right, we're coming back at you with more of that VMware Certified Professional version 6. Joining me in the studios today is none other than Mr. Don Pezet. Don, how you doing, sir?
I'm doing great, Wes. Ready to dive right back into vSphere and cover a extremely important topic out there in real life land, which is clustering and high availability. Up until this point, we've worked with ESX quite a bit and worked with vCenter and vSphere in general. And it's always been this kind of like standalone systems. Sure, I've been centrally managing them through vCenter, but each host was really its own independent entity. Well, that's pretty uncommon out in real life land. Maybe in a small business you might do that, but in a medium or large business, definitely in an enterprise, you're going to want your hosts to all work together. And that way, if you have virtual machines running on one host and something starts going wrong, you can just move the VMs over to another host. Even better, that can happen automatically, right? That's where we really want to be. And in order to do that, we've got to have a cluster. You have to be able to cluster together those servers so the hosts all know that they're working together, that they're not independent anymore, that they're part of a team. And that used to be a really daunting thing. I remember when I set up my first clusters, which would have been in the early 90s, it was really hard to do. It was just a big challenge to get those kind of things set up. But VMware's actually made it really easy. When you have the vSphere suite, and you've got multiple hosts that are joined to vCenter, we're just a couple of clicks away from having things clustered. So it's pretty straightforward. Where things get confusing is that vSphere has a lot of different availability solutions, and it's easy to mix them up. So what I'm talking about is technically called HA, or high availability. The goal of high availability is to make it where when a failure happens, nobody notices. Right? So a failure can happen on my network and my network keeps running just like normal. Nobody even notices. High availability is really, really hard to achieve. Because think about all the things that could go wrong. How many single points of failure do you have on your network, right? Okay, I have a server. I know the power supply could go bad, so I put a second power supply in there. Great, I'm covered. I know the hard drive could go bad, so I put in more hard drives. Now I've got a RAID array, I'm covered. I've got a CPU that could go bad. Ooh, that's a little harder, right? How do we recover from a failed CPU? You don't, right? So now I'm in trouble. Okay, so I add a second server. Now I have two servers. If the CPU goes bad in one, I've got the other server. Its CPU is still good, it's still running. So now I've got two servers. Great. Okay, they're plugged into a switch. What happens if the switch goes bad? Well, I just lost both my servers, even though they're actually up and fine, the switch is gone. So I get multiple switches. Wonderful. Now I need multiple routers. Now I need multiple internet connections. Now, what if the building burns down? I need multiple buildings. There's so many single points of failure in a network deployment that it becomes really super challenging to create true high availability. So when we talk about high availability, people are normally measuring it in downtime, like keeping your downtime to a minimum. And with VMware HA solutions, we can keep that downtime to seconds in the year. Really, really small downtime. But there is a lot more that comes into play. But HA is usually what we're talking about. We're trying to avoid downtime altogether. There is another technology built into vSphere called fault tolerance, FT. And with fault tolerance, what you're doing there is you're not eliminating downtime. The downtime happens. One server fails and people get kicked out, right? People see the failure. But there's a backup that fires up as soon as possible, and now you're back online again. You may have 30 seconds, a minute, maybe even 5 minutes in downtime, but fault tolerance takes care of it and we recover, right? The way high availability works is you have two sets of hardware and virtual machines that can run on any of that hardware. And there's a system in place that allows you to move the virtual machine from one set of hardware to another using what's called vMotion. So vMotion is where if I have two servers that are both connected to the same shared storage, then they can see the same VM DKs, the same virtual disks. So the only thing they can't see is what's running in RAM. If a virtual machine is running on host 01, it's got stuff in RAM. The host 02 can see the hard drive. It could boot that machine up from scratch if it needed to, but it can't see what's in RAM. So we have to have a way to synchronize that, and that's what vMotion does. It synchronizes the RAM from one system to another so that when we fail over, it's immediate and nobody notices, right? That's what HA can do. So vSphere HA can provide that. What fault tolerance does is fault tolerance just clones the virtual machine from one place to another, and it maintains a synchronized copy. And if one fails, it boots up the copy, but the copy is not running all the time. And so when you have a failure, your downtime is however long it takes that VM to boot up, right? So fault tolerance is different than HA. you can use them both together. You can have HA and fault tolerance. Maybe I'm doing HA here inside this building, but then I do fault tolerance between this building and my disaster recovery center. So if it's a hardware failure right here in the building, we can flip over, it's automatic, nobody notices. But if the building burns down, then it might take 30 seconds or 5 minutes for the disaster recovery site to kick in. Now, your building just burned down. Can you afford 5 minutes of downtime? I think most companies would say yes to that. But you might be mission critical, you can't even afford minutes of downtime, right? Like the New York Stock Exchange, they can't afford minutes of downtime. So what do places like that do? Well, they take high availability and they stretch it across their data center. And that requires a lot of money. It requires a lot of infrastructure. It's very difficult to achieve, but it certainly can be done, and the features are built in. All right, so those are some of the different things we're going to talk about. In the next episode, we'll talk about another one called DRS, Distributed Resource Scheduler. And a lot of people confuse DRS with HA, because what DRS does is it allows you to move virtual machines from one server to another. Well, that sounds familiar, right? Sounds like vMotion. But DRS isn't doing it for availability purposes. DRS is doing it for performance purposes. If it sees one server is really low on CPU resources, it might move some VMs to another one that has CPU resources available, right? So it's doing load balancing across your hardware. It's not really looking for failure. Now, if a failure happens, it'll balance around it, right? But that's not really its primary goal. So you may use DRS with HA. So see how there's all these technologies, and you can use them all at the same time if you want. There's actually only one that you can't use with the others we'll talk about later. But they all work together rather nicely. It's a matter of figuring out what it is that you need to deploy. So in this episode, I do want to focus on HA. I want to focus on the high availability side. And in order for HA to work, we have to have a cluster. Now let's talk about why we have to have a cluster, right? Let me look at my environment here. So I've got a host. And if I go in here and pull up my ESX host 01, right, here's this host. And on my host, I've got a guest. And that guest has a VMDK. It's got a hard drive, right? And that hard drive is stored in a data store. And so if I look at it here, Web01 has a hard drive stored in ESX host 01 local data store. So it's a data store that's right there on ESX host 01. If ESX host 01 fails, can I move Web01 somewhere else? No. The storage was there on host 01. If host 01 fails, I lost the storage too. I lost that VM. So I am not set up for high availability right now. If this one host fails, I'm in deep water. Okay. What I need is the storage for Web01 to be visible to other hosts. The problem is the local storage I'm using, it's a SATA hard drive plugged right into the motherboard. How can I make a SATA hard drive visible to other hosts? I really can't, not this way at least, right? What I really need is a storage area network, a SAN. If I have a storage area network, I can have disks that both of my hosts can see, or I might have 16 hosts and they can all see it. That's what a SAN does, it allows multiple hosts to see the same hard drive. But there's a little danger with that. The danger is, if I have two servers reading from the same hard drive at the same time, it's no big deal, right? One slows the other one down, but it's not a big deal. But if I have two servers try and write to the same hard drive at the same time, what happens? The data gets corrupted. It gets damaged. I lose my data, and that's absolutely not what I want. That's the opposite of high availability, right? So what we want is we need a system that can control that. That can say, yes, host 01 and host 02 can see the same storage, but only host 01 is allowed to touch it. And only if host 01 fails will we allow host 02 to touch it. They've got to behave themselves. We've got to teach them to not mess with the storage unless it's their turn. And that's what a cluster does. A cluster's primary purpose is to make sure that your hosts share resources nicely, that they play along, right? It's like a kindergarten teacher. You might not be able to teach them algebra in kindergarten, but you can at least teach them to play nice. And that's exactly what we're doing right here. We're trying to get host 01 and host 02 to play nice with each other. And by default, they don't. They don't play nice with each other because they're not teamed together. And so that's what I want to do. Right now, if I take a look at this, so I've got host 01, and if I take host 01 and I go to create a new data store, now I've got host 01 connected to an iSCSI SAN. So it is attached to a SAN. If I take host 01, I go to manage and storage adapters, I've got an iSCSI SAN defined in here, right here. So my VM HBA33. And if I come down and look at the devices, there's 3 1 terabyte hard drives attached to that SAN. Okay, so it can see all 3 of them, and that means it can use them if it wants, right? Well, if I jump over to host 02 and take a look at its storage, and storage adapters, it's connected to the iSCSI SAN also, the exact same one, and it sees those exact same drives. So they both can see the same drives right now. But if I were to add these as data stores to the machines, it would be a recipe for disaster because they're going to fight. They're going to fight for access to that, and they're going to corrupt my data. So I need to create a cluster first. And the way we do that is, well, if I start from the home screen, let me go all the way back to home screen. On the home screen, we're going to go to host and clusters. Now, I've been doing that all show long. I've been going to this for hosts. I don't have any clusters. But if I go to host and clusters, I can come in here and I can create a new cluster. If you just right-click on your data center, sorry, I clicked on my vCenter server there. If you right-click on your data center, you'll see where you can add a host if you've already got one, or create a new cluster. I want to create a new cluster. And so when we create a new cluster, it's going to bring it up, and I'll give it a name. I'm going to call this my IT Pro TV Lab. And then I can choose to turn options on and off for this cluster. Do I want the cluster to do HA, right, high availability? Do I want it to do the distributed resource scheduler? Do I want it to do virtual SAN or EVC? I can turn these on and off. Now, I don't have to do it now. I can turn these things on and off later, right? But if I want to, I can turn them on right here. Let's just run through these real quick. DRS, Distributed Resource Scheduler. I mentioned that one earlier. We're going to cover it in another show, but that's where I can balance based on performance. HA, that's where I can move VMs around based on failure, right? Moving them around to ensure that failures aren't noticed by my end users. That's what I really want. EVC. EVC is a enhanced vMotion mode. With vMotion, when you move a VM from one host to another, it expects the CPUs to be the same, right? If I've got 10 hosts, VMware expects us to have the same class of CPU in all 10 hosts. What if I don't? What if I have Intel i7s of one generation in one server and a different generation of i7s in another server? Or maybe I have Xeons in one server and regular i7s in another. When you fail a virtual machine over, if the CPUs are different, it has to reboot the machine. If it has to reboot the guest, that's downtime the users see. If we're trying to eliminate downtime, the CPUs need to match. Well, Intel stepped in, and AMD did the same thing and said, hey, what if we made our processors a little more friendly to that? And they made it where the clients can actually choose what features they see, so the CPUs don't have to match exactly. And if we do that, now you can take a vMotion VM, and you can fail it from one host to another where the processors don't match. And if there's extra features, they just don't use them. So that Xeon, its features kind of get scaled back a little bit for that guest. They don't get to take full advantage of it, but now they can fail over between processors that are different. That's really useful for people who are growing their server pool over time. Because a processor you buy today might not be available a year from now. And you don't want to have to upgrade your whole cluster. You just want to bring in these new machines that have new processors, and you just won't take advantage of their extra features, right? And that's fine. Now you can grow your pool and everything's fine. That's what EVC is. And again, we can turn that on and off later on. And then the virtual SAN. We're going to talk about virtual SANs in another episode. I really, really don't like virtual SANs. But if you don't have a real SAN, what you can do is use the local storage in your hosts as a fake SAN. And it will synchronize the storage between the hosts, okay? There's situations where that works out okay. In lab environments, it works great. In production, I really don't like to use it. But that's what a virtual SAN is, so we can turn that on too. All right. I'm going to leave them all off for now. We'll come back and do vSphere HA in a minute. I'm going to say OK to that, and it's going to create the cluster. So now I've got a cluster called IT Pro TV Lab. It's right there. But the cluster is completely useless right now because there's no hosts in it. And so what I need to do is I need to tell host 1 and host 2 that they're a part of that cluster. And there's two ways to do it. I usually just drag and drop. You can take the host and drag it and drop it. If you have two like I have, it's easy. You just drag and drop them. But if you've got 10 hosts, it gets kind of annoying dragging and dropping each one. So you can right-click on the cluster and move hosts into the cluster, right? And by doing it this way, you can just check the servers off. It's a little faster than the old drag and drop, right? So I'm just going to check them off and hit OK, and now it's going to move those hosts into the cluster. Now, what is that really doing? Not a whole lot, right? I mean, really, it's no different than a folder at this point. I've got a cluster, and inside of it I have two hosts, but the two hosts don't have any shared storage. They don't have any of the other stuff that I really need for a cluster to work. They just happen to be in the cluster. So really all I gained by doing that is the ability to do a common configuration. There's configuration settings I can do here at the cluster level that will now trickle down to these guests. So when I choose the cluster and I go to Manage and Settings, now I start to see all these different settings here, some of which I can apply on the individual hosts, others of which I can apply right here, and they'll apply to both hosts, right? And you'll see inside of the settings for the cluster, here's where I can come back in and I can turn on DRS, I can turn on HA, I can turn on a virtual SAN if I want. I've got all those different options, including EVC. So if I didn't turn them on before, now I can turn them on right here. So easy to fix this stuff after the fact. Cluster is actually really easy to work with. Now, a cluster without shared storage doesn't really do a whole lot for me. So I need to add shared storage. And I said earlier, if I added the iSCSI storage, if I added it to the individual host beforehand, I would have conflicts now and things would be bad, right? But at this point, now I can add them in and they'll play nice. And what's even better is I don't have to do it for each host individually. I can add the storage at the cluster level. And if I have 10 hosts, it'll automatically add the storage to all 10 of them. So it's easier to do it this way. Definitely easier to add it once you're in the cluster than to try and do it beforehand. All right. If I had added it beforehand, it does try to import it, but usually the damage is done at that point. If you have data stores tied to one host, those will come in just fine. But if you had shared storage, it's usually messed up by that point. All right, so I'm going to add the storage here. I'm just going to right-click on my cluster, and you'll see some of the different things that we can do, add host and so on. And I've got a storage menu, and I've got new data store. These are the same options I would have seen if I right-clicked on a host and done it. The difference here is it's going to allow me to add it to more than one host. So I'm going to add a new data store, and I'll give it some kind of a name, right? So it's asking me where I'm going to attach it, and it's got IT Pro TV Lab chosen already. I have no other clusters, so I don't have any other choices. And then what type? VMFS, NFS, or vVol. We're going to do VMFS. We talked about those back in the storage episode. And then I need to give it a name. Now I'm going to call this one, normally I name it based on the server that it's in, but in this one it's tied to a cluster, right? So this is going to be clustered storage. So I'll call it my IT Pro TV Lab, because that's the cluster, and then I'll just call it Storage 01. All right, so this is going to be the first storage data store in the cluster. Then I need to pick the storage to use. Here's where things get a little tricky, okay? The cluster isn't actually attached to the SAN, so the cluster can't see the storage. So I have to pick one of my hosts and say, look at the storage from the perspective of this host. If I have 5 hosts and they're all connected to a SAN, it shouldn't matter which one I pick. All 5 should see the same SAN storage if I configured my SAN properly. So it really doesn't matter who I pick, but I got to pick somebody. If I added a host and I haven't configured their HBA yet, they might not see anything. So I could take one host, configure their HBA, and view it from their point of view, and then the cluster will automatically configure the HBA and the other storage all for me without me having to deal with it. It makes life a lot easier. Okay, so at a minimum, you want to pick a host that's already configured. Mine are both already configured for iSCSI. They're just not connected to the devices. So when I choose it, now I see those 3 disks, and I can pick one of the disks. All right, so I'm going to pick that first one. They're all the same. I'll pick the first one and move forward. And now it's going to let me partition it out for VMFS. And when I finish, it's going to attach it not to one host, but to all of the hosts in the cluster. And if I add any new hosts to the cluster in the future, they'll get the storage added to them too. They will all get a direct connection to the storage, but they're not going to touch it unless it's their turn. The cluster is going to say whether they have permission to touch that storage or not, and that's going to stop me from getting data corruption. Right? And I had 2 other disks in there, so I could continue to add more if I wanted. I could just create another data store and just do the same basic thing. Unfortunately, you can't do more than one at a time for whatever reason. So I might create another IT Pro TV Lab, and I'll call this Storage 02. And I'll view it from the host. And again, I could pick one of my other hosts. I'll just stick with host 01, and I'm going to add this storage in. So just like before, it's going to create it and get it attached to both hosts. All right, now I can watch my recent tasks down here to see it churning along, and there it goes creating that data store. And as soon as it's done, I'll see it. My other one's already done though, so we can kind of look at it. If I take host 01 and I go to, whoops, if I get my mouse to freak out, and I go into my storage devices on host 01 shows, well, 2 Microsoft iSCSI disks, right? Which makes sense because I picked host 01 when I ran through the wizard. But if I go to host 02 and choose storage devices, it shows the 2 iSCSI disks also. It doesn't show all 3 because I didn't connect the 3rd one, right? And I never touched host 02. The cluster did that for me. I now have shared storage. If I create a VM and I put its virtual hard drive in that shared data store, both of my hosts can see it. And that's the key piece to allowing for failover. Now, if host 01 dies, Host 02 is connected to the same storage. Host 02 can at a minimum boot up those VMs, boot them up and get them running. If I know about it though, if I know that I'm going to be doing maintenance, right, I want to install an update on Host 01, I can move the virtual machines off to Host 02. I can do it while it's live, online, people in the server, nobody notices. And then I can take Host 01 offline, do my work, because Host 02 is already connected to that storage. I'm using iSCSI here, but it's the exact same thing for Fiber Channel SAN. It shows up the same way, we add it in, and we're off and going. All right. Now, my only problem is I've got a guest. I've got this Web 01 that's in the cluster, but Web 01, if I look at its related objects and data stores, I'll see that the only related object that it's got is ESX Host 01 local data store. So that virtual machine is still stored in Host 01's local data store. So even though Web 01 is showing is inside the cluster, see how it's nested in the cluster? I'm not actually going to be able to fail it over. Host 02 can't boot that up because Host 02 doesn't have that local storage. So I need to migrate this guest. I need to move the guest into the virtual cluster. It's a real cluster, but virtual, whatever. I need to move it into that cluster and move the storage into the right data store. Okay, well, it's already moved into the cluster, so I don't have to do that. But I do need to move its storage and get that put into the cluster. So if you right-click on that virtual machine and look at your different options, you'll see some different things in here, including Move To, right? Here's where I can move that guest somewhere else, and that's what I want to do. I want to move it. And when you go to move it, you pick your data center, right? So I've got my data center here on the list, and I'll choose OK, and oh, shoot, I'm already in the data center. I need to expand it out. And I can go to Host and Clusters, and I can choose that cluster, and I can even choose other hosts to move it to. But you'll see where I've got my storage also, right? And so I need to pick, and it's telling me over here where I can pick. I can pick a cluster or so on. Now, technically, I'm already in the cluster. If I hit OK, it's going to give me an error about that. I'm already in the cluster. I need to move into that storage. Okay. Now, my problem that I'm going to bump into here is that I'm already in the cluster. I can't move myself into a cluster that I'm already a part of. I just want to move the storage, right? The VM itself is already there. The storage is what's missing. So when you want to move just one piece, the Move To option doesn't work so well. If this virtual machine had been on a different host and I was moving it into the cluster, this would work just fine. But if I just want to move the storage, I need to go somewhere else. And let me show you how to do that. I'm going to cancel this, and I'm going to right-click on the host, and instead of right-click on the guest, and instead of choosing Move To like I did before, this time I'm going to choose Migrate. Migrate gives you some different options. Migrate's a little more powerful. When you go to Migrate, you can migrate the compute resource, which is what server you're running on, or the storage, which is what data store you're in. Or you can do both. You can migrate both, the storage and the compute resource. So in my case, the compute resource is already in the cluster. I'm already clustered like I need to be. The storage is what's not in the cluster. And so I'm going to choose to change the storage only. And when I move forward here, now I can pick the data store that I want to move it into. And I'm going to move it into IT Pro TV Lab Storage 01 because that's shared storage that both of my cluster nodes can see. If I pick any of these local data stores, that's not going to help me. And notice how the icons are all the same. They're all these little gray disk icons. And if I look over here, there's absolutely nothing in this table that tells me whether it's a local data store or a shared data store. That's why I always give it a name I can recognize. Your naming convention is really important. VMware doesn't have an official naming convention. You've got to come up with one. But that way you can tell which one is which. So I'm picking this shared data store, all right? And so now when I hit next and finish that up, it's going to clone the VMDK storage and move that into the shared data store and then get rid of the old stuff. And when that happens, now the guest is truly independent. Now the guest fully resides in shared storage and can easily bounce back and forth between host 01 and host 02 using vMotion or even just manually if I choose, right? When it boots up, you actually have what's called affinity. We're going to talk more about affinity later. So when I created that VM, I created it on host 01, so it's going to have a natural affinity for host 01. That's where it wants to boot. But if host 01 were to fail, I can boot it on host 02, right? The storage is now moved into this shared data store. So we'll see later where we can kind of customize that and make it where we don't even have that affinity. You can boot wherever you want. But right now, if I just started, it's going to end up on host 01, and then I can move it. Now, there's still more work I need to do before this cluster works properly, but technically, we're now in a cluster. We're in a cluster, we've got shared storage. If I create my VMs and I place them in that shared storage, they're going to work just fine, and I can start using things like vMotion. But there is a little more that has to be dealt with. For example, how does one cluster node, how does one host know that the other host is online or not, right? One host could fail, the other one needs to know. And so there's what's called heartbeating that needs to be configured. Heartbeats are how the servers see each other. And there's actually 2 different ways to do heartbeating, so we'll kind of talk about that a little bit. I know I'm probably too low on time to talk about it now. But we need heartbeating configured. There's also advanced functionality in the cluster. So I mentioned like EVC, the enhanced vMotion. With enhanced vMotion, I can move between non-compatible processors, or it's not that they're not compatible, so they're just different feature sets. And those are all advanced functions of the cluster itself. Let's take a look at this real quick. If I take the cluster and I go into settings, there's a lot of stuff in here I can configure. So EVC was the one that I mentioned, right? And with EVC, you'll see that it's disabled by default. And I can edit this. And in my case, my 2 hosts actually do have identical processors, so I don't actually need it. But in the future, if I'm going to add a 3rd host, and the 3rd host has a newer processor, it's different, then I would need to come in here and turn it on. And notice there's 2 different modes, one for AMD hosts and one for Intel hosts. In your cluster, you shouldn't mix Intel and AMD. You can, but vMotion will never work between Intel and AMD. They're too different. I can have all AMD or all Intel. And if they all match, great, I don't need EVC. But if there's a variation in between them, that's where EVC comes in. So it will correct between AMD processors, or it'll correct between Intel, but it won't correct between both. So you got to pick. In my case, I've got Intel, so I can go ahead and choose that. And then I pick my EVC mode. And what you're doing is you're picking a feature set that is supported by all of your processors. So basically, you need to look at all your processors and figure out which one's the oldest. Which one's the oldest CPU? And then you pick the generation of that CPU, and that's what your virtual machines will use. And so you might have Penryn processors, or Nehalem, or whatever. And if you have those, there's newer ones, like Ivy Bridge, right? Is Skylake in here? Haswell? Skylake's not here yet, but I might have Haswell processors. And those have a lot of extra features, more cores. But I won't be able to use them because I've picked Nehalem, right? So you pick the lowest common denominator, the oldest processor, and that's the one you go with. As you phase those processors out, as you replace those hosts, then you can move up to the next level or the next level, and you pick that generation. AMD's done the same way. I don't think it'll error. It might error out on me. Yeah, I'm getting a bunch of warnings down here because I don't have AMD processors. But you'll see where you can pick those Opterons, and you can do the generations and so on, all the way down to the newer PileDriver and Steamroller. You just pick the appropriate level. That's the minimum level supported, right? So that's what EVC does. You get it turned on, and it's in place, and now you're taken care of, right? So it's enhanced vMotion CPU is what EVC is, and it just gives you that compatibility. So that's something that we can turn on. I'm not going to turn it on mine because my processors are identical. I don't have to worry about it, right? That kind of covers us. If you don't know your processor, you can choose a host and go to its summary page, and it actually tells you on the summary page as soon as it loads there. So see how I've got an Intel Core i7-4558U in this one? And if I go and take my other one, it's got the same Intel Core i7-4558U. They've got the same processor, so I don't have to worry about EVC. All right, other things that we can customize in here, you'll have things like disk management, right? This is for the virtual SAN. Now, the virtual SAN is a licensed feature. You have to have a license dedicated for that, and we're going to talk about it in another episode. But if we want to come in and configure the virtual SAN and disk management, you do that all from here. Otherwise, we have our licensing, and the only license we have to worry about is the virtual SAN license. Otherwise, clustering is built into vSphere. You have clustering support even in standard edition. Foundations, the most basic version of vSphere, has clustering. So the only time you need licensing is if you're going to use vSAN. We've also got other host options that we can tweak. Notice here that I've got my host and there's no power profiles defined, right? If I want to define power management, we don't normally want to do that. You don't want your machines to go to sleep. But we're going to talk about power management in DRS with the distributed resource scheduler, because I might have 100 hosts, but if the system is slow right now or idling, we could shift our VMs over to 60 hosts and power down 40 of them and save a lot of power. And it can do that if we turn on power management. So other things like that can get configured. We'll see that in DRS. But for the most part, that's all we want to configure. We're going to see a little bit more of these in the DRS episode. I do still need to configure HA. I created a cluster, but I'm not running HA. And what that means is if I have a node, if I have a guest, my Web 01, if it's running on host 01 and host 01 fails, it just goes down. That's it. Host 02 could power up that VM, but it's not going to do it by default. I have to turn on HA for that. And if I'm going to turn on HA, I got to get heart beating turned on. I've got to get those configurations put in, and that's where I don't have enough time in the episode to do it. So Wes, we're going to do a part 2 because I need to actually show getting HA turned on. We built our cluster. That's step 1. Now we need to get HA turned on and define when we fail over and all that other information, which is what we'll have to do in the next episode.
I was going to say, with an episode called Clustering and High Availability, chances are we should explain HA as part of it. But Don, you've already stated the obvious here. It does look like we're coming to the end of the next episode, or this episode. Did you have any additional words that you might want to say, or maybe just save it for high availability?
One thing I didn't mention is if you're going to cluster, you really need to go to VMware's website and check their hardware compatibility list. All of your hardware needs to be supported on the HCL. If it's not, the cluster might not work reliably. Nothing I did here was really a big deal, but when we start getting into HA, it's really going to matter. And so it's got to be on their hardware compatibility list. If it's not, the functionality can be messed up, and what you think might be a highly available solution might actually turn out to be pretty unstable.
Well, check those HCLs, that's for sure. Well, Don, as always, we appreciate you being here in the studios, and we appreciate you, the viewer, watching. Come back and see us for a part 2. But until then, signing out for IT Pro TV, I've been your host, Wes Bryan.
And I'm Don Pizzette.
And we'll see you next time.